Hi, good morning, dear students. Today we are going to discuss about 8086 microprocessor. Already we have seen introduction of 8086 microprocessor. Micro, what is microprocessor? Microprocessor is nothing but it's a part of the CPU. We can say it. Okay, what is it mean by microcontroller? Microcontroller, it's a advanced version of microprocessor. We can say otherwise microprocessor it's a wherever we are using counter and timer. Based on that timer counter and timer, that we can call it as a microcontroller. So here we are using 8-bit register. In microprocessor we are using 16-bit registers. Okay, so now we can go our topic, that is called 8086 microprocessor. Here, yes, totally two units are there. One is first interface unit, another one is execution unit. So shortly we can call it BIU and BU. So here many registers are coming. What all registers means? First register come general data registers, a pointer register, index register, instruction pointer, and segment register and clock registers. So what is general purpose register? General purpose register means AX, BX, CX, and DX. These all register 16 foot, and remaining AX stands for AL and AH. PX stands for PL, PH. So likewise CX and DX. So same thing here, we are using 18-bit register and pointer register. What is pointer register? SP and PP. SP means stack pointer, PP means space pointer. There also 16-bit register. Index register. Index register means one is source to destination. Source index, another one is destination index. And next point it is instruction pointer. Instruction pointer, it's a 16-bit register. And we are going for the segment registers. What are the segment register? CS, DS, SS, ES. So CS means code segment, DS means data segment, SS means stack segment, ES means extra segment. And flag register, it is totally 9. It is that one is control register, another one is control flag register, another one is unconditional registers. Totally 9 registers are there, flag registers. Okay, here what will the work of was interface unit and execution unit we are going to discuss. So first of all, first interface unit, uh, segment address are there. Segment address what all? ES, CS, SS, DS, and IP. So IP means here instruction pointer. So all the data, all the registers, it's going to ALU. ALU means arithmetic logic unit. So it's moving to the performing one by instruction queue. Instruction queue means it's one type of pipelining, we can say. So 1 to 5, 1 to 5 or 1 to 6. So one by one instruction key code. After that, it's proceeding to the operands and flags. So and the remaining where are the data segment register, general register, pointers, instruction flags, everything is performed in the execution unit. So how this performing, based on that, how we are sending the data and how it is work out. So based on that, we can see one by one actually. First of all, we are going to see execution unit. Execution, what is the work of execution unit? Execution unit executes instructions that have been fetched by BIU. What are the details? What are the memory or data we are going to queue? So execution unit, how it's performing. So these functions, so it's going to fetched by the BIU, bus interface unit. So here, what is bus interface unit? Bus interface unit instruction reads data from memory and IO ports, writes data to memory and IO ports. So whatever here we are giving the instruction, first of all it's read and after that writes. So based on that, so that is the main work of first interface unit. Okay, next, microprocessor. Uh, in microprocessor, first interface unit, totally 4 segments are there. One is code segment CS, data segment DS, stack segment SS, extra segment ES. Okay, so these are the 4 segments, totally 16-bit segment register. It's a 16-bit segment register. So how it's performing? So in this all the 4 register, it's flowing to the offset address. Based on the offset address, so this is the registers we are having in bus interface unit. After that, it's moving forward to the instruction queue. Yes, whatever the data or register, it's moving from there to here. So everything is coming as a instruction queue based on the instruction queue after performing. So it's executing through over the execution unit. Okay, so that is arithmetic logic unit. So arithmetic logic unit, it's performing addition, subtraction, multiplication, division. Already we know it very well. So based on that, operands and blocks. Operands means like a plus b. It means operands means a, and b will be the operands. Opcode means plus. So opcode and operands we are going to like performing in the like BIE and execution unit. So in execution unit, so we are going to cover like general purpose register, that is called AX register, accumulator register, pace register, BX register, C count register, CX, and DX means data register. These all four registers for 16-bit register. So how we are going to higher and lower order? AL, AH. N stands for here L, H stands for here higher order. At the same followed by the base register, counter register, and data register. It's everywhere 8-bit registers only. Yes. This is called general purpose registers. Okay. So another options we can say SP pointer register. Pointer register, that also it's a 16-bit register, SP and PP. It means stack pointer and base pointer. And another one is we can see index register. It's a SI and DI. Source index and destination index. Instruction file means IP. That is called IP. That also 16-bit register. Segment register means already where we say seen at execution unit, CSDS, SS and ES. Flag register totally 16-bit register. Okay. Name of the register 16-bit accumulator, 8-bit accumulator, page register, count register, data register, stock finder, source index, data action. Many like registers are there. Like we can see one by one segment registers. First one, yes. First interface unit, we can see the code segment register, CS. So CS, how we here we it's performing. So normally 0 to 15. Total it's a 16-bit register. So it's performing 16-bit. Normally accumulator register, how it performing? So AH and AL. AH means higher order, L means lower order. So based on that only code segment register its work. It's 16-bit register. CS contains the base start of the current code segment. IP contains the distance from the offset from the address next in by to be fetched. And totally 20 physical addresses are there. CS 4 bits and less than 16-bit contents of IP. And after that, we are going to discuss data segment. This also 16-bit segment register. So how it's performing? So operands for most instruction are fetched from the segment. So this also 16-bit contains, so 0 to 50. The source index and destination index 16 feet displacement are used offset for computing the 20 feet physical address. So next one we are going to discuss stock segment register. Segment register means this also 16-bit register points to be the current stock. So based on the pop push options, we know it very well. This also 20-bit physical stock address calculated by the SS stock segment and base binder. And finally, we are going to see the last one segment register, that is called ES extra segment. This also 16-bit register points to be the extra segment which data is stored. Okay, string instruction the ES and DN determine the 20-bit physical address for the destination. Okay, so and after that last finally, so we can say it's a segment register based on that instruction pointer. So this also 16-bit register always point to the next instruction to be executed with the currently executing code segment. So the register contains 16-bit offset address pointing to the next instruction within the 16 core KB of the segment area. Its contents it's automatically incremented to the execution next instruction takes place. So first interface unit. So here a group of FIFO means first in first out, which have 6 bytes of instruction code are fetched from the memory to the time. Okay, this is done by order speed up executed overlapping instruction fetch with the execution. Okay, this mechanism is known as pipeline. Okay, and after that execution unit we are going to discuss. So EE decodes the execute instruction. A decoder is the control system translate instructions. So what all already we discussed, So for general purpose registers, pointer registers, and index registers and flags. Though these will discuss one by one next class. Thank you.